Hi, everyone. Welcome to this talk. If someone can confirm in the back that they can read the code in the code editor, or if I need to increase the size a little bit. How's that? Okay, I see a thumbs up. Awesome. So thank you for coming to my talk. One of the questions I get a lot, because I mentor some students and early career professionals. I've been in the industry for 7 years, and I have good amount of experience in infrastructure engineering, specifically working with cloud providers. And the question I get is how to build cloud projects. And that is something that I have struggled myself, because I advocate that you need to have hands-on skills, and you get that by building projects, specifically if you're a student, because they don't have a job where they can apply these hands-on skills. So what better way to ask ChatGPT about a cloud project? So certain times, these professionals or students would ask me, hey, I'm learning XYZ certification. For example, we'll take Azure today. So Azure has a bunch of cloud certifications. AZ-104, AZ-204 are some of the popular ones. And I told them, I'm like, hey, ask ChatGPT, because now we have AI that can help us. The thing is, the responses that ChatGPT gives, it varied over now we have had ChatGPT for 2 years. So it varied over the time, because earlier, maybe it was not trained on really good data from Azure certification. And also there's the limitation that what kind of data it was trained on. So here I have a Python script called starter.py. And if I scroll up to the top, you can see I have basic imports. So if you're familiar with Python, I am importing, very crucial, LangChain OpenAI, because I'll be using OpenAI today and their large language models for the example or the talk today. But you're free to use any models like Gemini from Google, or even open source ones. And if you look down, I have a function called ask LLM. And basically, it takes an argument, query, and down, you can see that I'm invoking the LLM. So it clearly says chat OpenAI. This is what is initializing the large language model so that it can talk to the OpenAI's API. Now I have a .env file set up for my OpenAI API key. Again, I'm not going to show that, but you can get your own API key. It is necessary if you want to follow along with this talk. And basically, I'm asking LLM, can you help me with a project idea for AZ-104? And I want to try it out, because not everyone knows what AZ-104 is, but it's basically a certification code that Microsoft uses for Azure Administrator. So let me try running this starter.py and also get my mic fixed here, because I can't type with one. Check. Awesome. So let's do simple Python 3 starter.py. And let's see what it returns. OK, a bunch of text. But if we look at it, I have to take the mic again. Bear with me. We have 40 minutes to kill. So if you look at it, it says, sure, here are a few project ideas for AZ-104. Create a virtual machine in Azure and configure it. OK, it's pretty generic response. But what happens when Microsoft releases a new version of the certification? Would OpenAI go and train the model again tomorrow? Maybe, because Microsoft is a huge investor, but who knows? But you can take this concept and kind of have this in mind that, hey, we might have our own knowledge base. You might have your own data that you want ChatGPT or any of the models to be aware about without needing to retrain OpenAI's or any large language model, I alone, with the compute power that I have within my resources, cannot train a large language model. And I'm pretty sure it's probably true for a majority of you. So we'll look at some innovative ways on how you can make ChatGPT aware with your own data, like how it can be aware of your own knowledge base. If this is for a business use case, even for personal projects, it works pretty well. And let me get to the slides now. I know some people might find it boring. I am not into front end, so I also cannot design UIs. So my slides are going to be pretty much as my terminal is. It's going to be a dark screen with white text. So let's see if we can figure out swapping screens. Awesome. So LangChain Legends is the title of this talk. I've been told that to come up with creative titles to get accepted to conferences. So that is me trying here. But today we'll learn about LangChain. It's an open source framework, and we'll see how you can build large language model applications yourself and what LangChain brings to the table. Who am I and why I'm yapping? So I'm Rishab. I'm a staff developer evangelist at Twilio. I'm also a GitHub star, AWS community builder, and a Google developer expert. But I'll have the QR code thing at the end for you to scan, connect with me if you have any questions. But let's move on. Since we'll be building out an LLM-powered application, there are some prerequisites or requirements if you want to follow along. Python. You need Python on your system installed. Any version higher than 3.9 works. And also, I'll be using pip, but you can use any of the Python package managers. Code editor. So for me, VS Code works because it's free, and I've been using it for years. You are welcome to use whatever code editor you like. And as I said in the beginning, you'll also need an OpenAI account. The reason is you'll need to grab an API key so that your application can talk to the OpenAI large language model through their API. Awesome. So what is LangChain? LangChain is an open source framework, all things open. And it allows you to build your own large language model applications by bringing in your own data and compute. The framework is currently in Python and JavaScript. So those are the two languages that they support. And it's mostly focused on composition and modularity. So in simpler terms, LangChain allows you to plug in GPT or any other large language models into your own data. Awesome. So there's a lot to unpack when it comes to LangChain. And new stuff is being added every few weeks, even months. I remember I was trying out LangChain very early on as soon as it came out. And I have a free codecamp course for LangChain that you can look into if you're interested after today's talk. That course was outdated within 3 months. That's how quickly this framework was being built and evolved, and things were being fixed. But in a nutshell, these are some main concepts within LangChain. So the first one is models, or also known as LLM wrappers. This will allow us to basically connect to OpenAI's GPT 4.0 or GPT 3.5, or any of the other models from Hugging Face, from Google. Even if you're running large language models or small language models, which is another term I recently learned, on your local machine using Ollama, you can also connect with that using LangChain. Second is prompts. Prompts allow us to set a certain kind of instructions to guide the model's response. And there are a few interesting talks around prompt engineering. That's where those prompt engineering skills come in handy. Third is chains. So pretty self-explanatory, but it basically allows us to connect multiple components within LangChain together. So you'll be seeing an example today of connecting models and prompts together using a chain. Then we have indexes. So indexes allows us to extract relevant information that is required for a specific response. And we also have agents, which I'll not be touching base on, but they allow us to take action. So let's say there is an external API. I work for Twilio, so we do a lot of communication. So let's say you want to, at the end of whatever your LLM does, you want to send out an email or an SMS. So you can connect external agents and APIs to perform that action. Awesome. Now, let's move over to seeing these concepts into action with our basic app. I'm gonna quit the slideshow, and we should see our code editor. Awesome. So now, within our starter.py, let me close out this, or minimize this terminal, and I'm gonna copy most of this code until my function. Awesome. So now I have a file called ai.py, going with the theme here, and I'm gonna paste that basic function we had in Python, which basically is asking, it's very similar, and some of you might say this is very similar to asking ChatGPT in the web browser about a project idea. But this is in code, and it makes it cool? No. This is in code, and we can make it more powerful because we have that ability. So now, right after LLM, we saw that on the slide. The second concept was prompt templates. So I'll be using a new variable called prompt, and we'll start our prompt template. And for anyone who is wondering what this autocomplete is, this is GitHub Copilot. I should probably disable it, but let's see how accurate this is during this talk. So prompt template, let's go with whatever it's suggesting. I'm a chatbot that can help you with Azure certification. Ask me anything about Azure certifications. No, I'm not happy with that. So there are a few things you can define within the prompt template. And again, all of this is available on LangChain's documentation. But what I really care about is the template itself. And I'm gonna cheat. So there's a README file here, which has a pretty cool prompt template. It was selected, I just unselected it. Let me copy this and go back to our ai.py and paste it in here. Okay. So I can quickly go over what it says. Okay. So it says you are a helpful cloud instructor that provides cloud project ideas about Microsoft Azure certifications based on the certification guide. Give me a project idea for certification, and this is where another kind of concept comes in. As you can see, this is a variable that I'll be using called certification because I want the user, in my case, most of the students, to be able to select a certification for whatever they are studying, and also of the level, if it's a beginner, advanced, intermediate. So giving them that ability, along with, here's an Easter egg, we'll get into this, but by searching the following certification guide, and it's linked to docs. So that is where our custom knowledge base will come in, which will be built by using Microsoft's official study guides. And then it goes over, only use the factual information from the guidance to provide the project idea. If you feel like you don't have enough information to answer the question, say, I don't know. This is some of the prompt engineering skills that I have gathered over a few months. But I also give it a markdown structure so that, we saw that in the terminal. That didn't look beautiful. It's very confusing. So I wanted to use Markdown to respond me with the project idea. It should include project name, project description, the services used, and then also the steps to build that specific project. Now, talking about input variables, let's add them to our prompt template. So how you can do that is within our prompt, I'll just type in input _ variables. And we saw that there was certification that I want the user to be able to control, and also the level of that certification. We'll also do docs for now. But if I go up, we have to get rid of this query as the argument within our function, because now we are using other input variables. So certification is one, level, and then docs. Awesome. I didn't spell that correctly. Certification. There we go. And we'll also change this function's name from ask LLM to project idea. And I want to come back to the slides now, because this is where another interesting topic comes about vector stores. So let me get to it. So we all know that these large language models, they're trained on, anyone guesses? I'm specifically looking for type of data. Text, okay. Okay, yeah, so, yep, unstructured data, right? Or unlabeled data, because they just decided, okay, we are gonna go to Wikipedia, we're gonna go to all these text-based, books, profiles, and train these models, but the data itself was not labeled or structured. And one of the most common ways to store that data is by using vector stores. So what you do is basically, with that unstructured data, we embed it and store the resulting embedding vectors in the vector stores. So to build the custom knowledge base, I personally today will be using Azure AI Search, but you're more than welcome to use any of the other providers like Pinecone or VV8, some names that you might have heard of. And the knowledge, as I said, will be the Azure certification guides itself. That is also when, I know if you were here for the previous talk, there was some discussion about token limits and how there are limitations with this large language models. So that is where also another concept of chunking comes in. And because we want our large language model to reference a document, in my case, it is certification guides, and they're huge. And there are some limitations due to those token limits on how much context you can provide these large language models with your input. Chunking ensures that the input text doesn't exceed those token limits, but also it improves the accuracy, relevance, and efficiency of the search results. So what we'll do is we'll take our documents or the certification guides, we'll chunk them so that they are optimized for the model that I'll be using. So GPT 3.5 Turbo, top of my head, I don't know what the token limit is, but you can Google that. With 4.0, the token limits are pretty huge. And specifically, Gemini, I think, is doing a great job with 1 million context window, which is very big. Correct me if I'm wrong. But yeah, they have huge limits. But since I have only a certain amount of credits in my account, I'll be using 3.5 Turbo, which has very less token limits. Hence, this chunking needs to be done so that I can store my certification guides, chunk them down into smaller docs, and then store them into the vector store. So let's do that next. And I know there's a lot of switching between slides and the code editor, so bear with me. OK. Now, I have a file called knowledgebase.py. And on top, as you can see, what's happening is the LangChain people are amazing because they have these community helper libraries or functions available, and they support Azure Search right out of the box. Similarly, this is available for other providers if you're using any other vector store or databases. And then also, I'm doing an import for OpenAI embeddings, because I'll be using OpenAI's embeddings model to embed the text that we'll have. And I'm also using the text splitter. Again, this is available from LangChain. So as you can see, I have a list of URLs from the certification guides. So this is the entire list. There are currently 1, 2, 3, 4 certifications that I support, or my project supports. So AZ 104, 204, 305, and 400. And there's already some code here. So this code block is basically settings that I need to configure the vector store. This is pulling information from my .env file. So the Azure Search endpoint and Azure Search admin key is needed to connect to my vector store within Azure. I'm naming the index as LangChain Vector Demo. And then I'm using those settings to connect to the vector store. So this is my initialization of the Azure Search vector store. Now, here I have a comment saying load and chunk the documents. So we'll start doing that with defining a loader. So since the certification guides are on the web, I'll be using the unstructured URL loader. Basically, it extracts the text from the websites. Oh, Copilot coming in handy. I don't have to type that all out. So unstructured URL loader, and then I'm passing in the list of URLs that was stored in URLs. And then the next thing is documents. I will save these loaded documents into the variable called documents. That is not correct. So it is just loader.load. And there we go. Now I'll be defining a text splitter. And I will be using character text splitter. There is different text splitters available. You can look into that. LangChain has a pretty good documentation on which might work best for you. So since my entire data is text, it's pretty easy to use this one. But there are 2 settings that I want to point out. One is the chunk size. And the next one is the chunk overlap. I have a tilde sign that I don't need. Chunk overlap. And we'll set that to 200. And I'll quickly go over what this means. So chunk size, no, I don't want 5,000. 2,000. So we have a big certification guide, right? Now we are chunking it into smaller chunks that are being created. 2,000 is what will be the character size. So the first piece of smaller chunk will be created will be of 2,000 characters. Similarly, next. So one document will be split into multiple smaller documents. Now, what chunk overlap does is, since I have it set to 200, the last 200 characters of the first document will also appear on the next one. And similarly, a chain kind of structure will be built. This is so that LLM doesn't lose, when it's doing a query on this data, it doesn't lose context when there's a line that was really important. Let's say there was a line about Azure Administrator, and right there the document got split. So it knows that it has to also pull the next document. So that kind of context awareness is why chunking and this overlap strategy works. Again, I'm not an expert on chunking. There are definitely a lot of great articles and talks available on this that might work best for your use case. This setting works for me. So now, after we have initialized the text splitter, I want to use that against my docs. So also, I want to make sure we are doing good on time. So what we'll do is we'll create a variable called docs. We'll use the text splitter that we initialized, and we'll use the function called split documents, and we'll pass in the certification guides into that. Now, we also have search that you can do. So Azure AI Search supports different kind of searching. Most of the vector stores support them. So like there's similarity search, there's hybrid search. You can look into that. I'll be using similarity search today because I want all the relevant docs for a given certification. So what we'll do is we'll do a similarity search quickly after we add these docs to my vector store. So in order to add that, I'll do the add underscore documents, which is a function, and we'll add these docs to my Azure AI search vector store. Now I can do a similarity search. Look at Copilot. No, that doesn't work. So I will call a new variable. We'll still name it docs. And then I'll say vector store dot similarity search. And the query is what we'll search for is, let's say, Azure administrator. And we can also set a value for k, which is how many docs should be returned. So let's set it to 3. And I'll quickly do a print statement. And we'll print the docs. OK, now let's go to our terminal, make it a little bit bigger, go down, and run our knowledge base.py. So what this would do is we'll chunk the documents, store them, or embed them, and store those embeddings in the vector store within Azure. And then also, we are doing a similarity search to retrieve certain documents from that vector store. So knowledge base.py, and let's see what happens. It should take some time because it's doing all of that chunking, storing, and then also retrieving it. So we'll see. Hopefully, we don't get any errors. OK. We did get an error at the end, but I did also see the doc. So let's go over it. So we have our first document starting right over here. We have the metadata. So this is the metadata about that specific smaller doc. We also have the source. As you can see, this is from the Microsoft Learn. And then we have page content. So the page content is actually from the guide. It says skill measured prior to October 26. This is all from the website, from the official Microsoft study guide. But what we really care about is page content. So we could make this cleaner for our application itself. For knowledgebase.py, since I just wanted to show you this, it works. Now, let's go over and implement this into our application that we were building. So I'm going to go over to my AI.py file. But since a lot of the code for the vector store is kind of written, I'm just going to copy this. So this will allow me to connect to the vector store that we just created. So if I go up, right after loading the environment variables, I'm going to insert those code blocks in. And I'm also going to initialize the OpenAI embeddings because we were not doing that. It is needed to do the search. And right within our function, we can kind of copy and repurpose the search we built below. So here, I can copy this and paste this in before initializing the LLM. So we are doing a similarity search. The only thing that needs to be changed is we don't want to hard code the certification. We want this to be the certification from the argument that we had previously configured. So this. Now, the next thing is we also have to join the docs. Since the docs themselves, they'll be returned separately. What you can do is you can join them into a single text and give it to your large language model along with the query we will have from the user. So I'll do a simple join. And we'll specifically look for page content because we saw that that is what we care about. Other fluff can be left out for the, for the in docs. So that will give us those 3 documents that was retrieved as one single. And K is set to 3. We can set this to 4 based on the size of the chunks. But I'll leave it to 3 and see how we get, how good of a response we get from OpenAI. And also, I'll be using just OpenAI here. So let's do OpenAI. I think that defaults to 3.5 Turbo, but let's see if LangChain have changed some things. You can also define the model within this initialization. So you could be like model and then specify the model name. Now, what is also left is instead of invoking just the LLM, we want to invoke the chain, which we haven't created, which was the 3rd concept on that slide. So the chain is pretty easy to create. It just goes prompt, pipe, LLM. That's the chain, because it'll use our prompt template, and it'll use the large language model that we have. Now, for the response, we'll do chain.invoke. And we'll have to map the input variables to the arguments from our function. So the input variables were things like certification level and docs within our prompt template. I want to map that to the arguments that I'll get in the top level function within my Python file. So I believe this is a good suggestion from Copilot, so I'm just going to hit tab. There we go. So it's pretty confusing because certification is mapped to certification, but it makes sense. Now, for the print statement, we can get rid of this. The reason being, I do have a Streamlit app. So how many of you are here aware about Streamlit? I see a few hands. Cool. Yeah. So in the beginning, as I said, I don't really know how to design front end and also build front ends. Streamlit helps me there because I can do that within Python. So let me save my ai.py file quickly. And let's make sure there are no errors. Awesome. And I'll quickly show you the Streamlit app that I have. Let me go on top. So as you can see, it is importing AI as AI, and that is our ai.py file. It is also importing Streamlit, and this is the basic design. So the Streamlit title is set to Cloud Project Generator. It has 2 select boxes. So one of them is the certification, and the second one is the level of certification. And then it uses those values and passes it to the project idea function we just created as arguments. Awesome. So now, let's run this. Streamlit, run streamlit.py. And that should open a browser tab or localhost 8501. Let me find my browser now. OK, I have my browser here. And we have got an error. That is the fun of live demo. So the error is, let me zoom in a little bit. Perhaps you forgot a comma. That is pretty easy, hopefully. So let's go to our code editor and look at our ai.py. So we forgot a comma somewhere. Oh, right here, I think. There we go. Let's go back to the browser window, hit refresh. Seems like it's running. And we have some more errors. So it is missing the argument within our project idea function, which was not supposed to be an argument. So I should really pay attention when Copilot suggests things. There we go. Is that better? Why is it giving me, oh, it also got rid of the, awesome. Okay, third time is the charm. Let's see if it is. Awesome. Why can't I scroll? Okay, there we go. So by default, it took AZ-104 and a beginner level certification. So this you can change. And it gave me back a really robust project idea called Azure Resource Manager Deployment Automation. It has the description, it has the list of services that will be used, and it also has step-by-step instructions for folks who want to build this project. The good thing about this compared to the simple ChatGPT response we had in the beginning is this is in alignment with the certification guide. So people who will follow this project will really have hands-on skills that are comparable to the exact certification. So the robustness of the response is better than to simply ask ChatGPT about the project, which we were doing earlier within our LangChain app. Now, this is called something that you might be familiar with, called RAG. So RAG is the process of optimizing the output of the LLM without the need to retrain it by providing it a knowledge base or knowledge that is needed or context that is needed for the robust response. So RAG, in a manner, extends the already powerful capabilities of large language models, just that you are providing your own knowledge base. So you can think of internal documentation, or also, like I gave an example where, what if a new certification is released tomorrow? So this app still can be used for that purposes. And as I said, I don't have the means to retrain an AI model as of yet. Maybe in 15 years, who knows? But yeah, so retrieval augmented generation really helps with creating this kind of a general pipeline that you might have already seen a similar diagram. So the input comes in from the user. That same input is also used to do a similarity search when it is also passed to the LLM. Similarity search gives us relevant docs that we saw in my certification example. It was the guides. That guides are passed on to the LLM along with the input we had from user so that the LLM can make an informed, it can have an informed response in making our answers more robust. So I'm really excited to see how you leverage this demo to build your own LLM-powered applications with LangChain. It could be for personal or professional use cases, and I can't wait to see what you build. And the possibilities are limitless. So thank you. I am Rishab, and here's a QR code. As I said, I promised you can connect with me if you have any questions. You can ask now. We also have like 5 minutes. So you can also reach out if public space is not your thing. You can reach out to me on social media, any of the platforms that work for you. It'll also have link to a GitHub repo for today's demo, and also the free Codecamp course that I was talking about around LangChain, which is also free on YouTube, so you can check that out. Also, I would really appreciate if you can provide me feedback. So I'm trying to improve my skills of giving technical talks. I would really appreciate it if you can provide feedback about this talk, how I can improve, and what are some things that you might didn't like in today's talk. Oh, I was smart. I have a slide with both of the QR codes, so you can connect with me on the right or your left, and you can also provide feedback for the QR code. It's on the right-hand side. Thank you.